So now that you clearly have energy because you just consumed Twix, the candy bar with a cookie crunch.
Was there anything sauce? And you made eye contact? And then you close the door.
I left the door locked.
Thank you. Stop it, I would love
You guys were not exactly sprinting down the hall. You were.
We were doing a fast walk.
I have little legs.
I am out of breath now.
You're a demon. Meg is clearly completely out of shape. She's supposed to be pretty
Very out of shape.
And you're a volleyball player, although that's not necessarily long distance running. It's short bursts of movement.
I don't have to move very far. That's the only reason I'm
But you have to move there very quickly, right? You have to move like
fair.
2 feet this way really fast.
Yeah.
Volleyball's not a sport.
What did you say, Logan?
I said volleyball's not a sport.
I thought tennis is
Can you imagine if someone did like dive and roll out drills for 20 minutes? They'd be out of breath. 20 minutes
We
straight,
did
just dive and roll out.
20 dive lines yesterday.
That's what I'm saying, like, that'll get you going, right? I mean, there's some endurance involved for sure. Or, how about just like continuous hit loop for a half hour, like with 2 or 3 people sharing?
Did we hit that?
No, transition off,
Oh, God.
approach and
Oh,
swing.
that's so
Transition
sad.
just like over and over and over.
That's the worst thing ever. I don't know how hitters do it. Because my coach last year made me do it with them.
Yeah. I've done it before too. I thought I was going to pass out after. I don't know exactly how long that was, but I remember doing it as a coach like 7 or 8 years ago. At the time, Coach Nielsen said, "Hey, I need like an old guy to hit at my hitters because like I can tool really easy and shape shots and stuff." And so there were supposed to be 2 of us, but the other guy like disappeared. So there I was, one person. Like 10, 15 minutes later, I'm like, I'm done. My vertical went from like this to this to this to this to this. And it's like, I can't jump anymore. Hey, enough with the Twix.
Hey,
I have an actual serious question. Hey, I have a serious question for you guys. What can I do to get you guys to check out intro activities better? Because as it stands, like 3 of you checked out the intro video for this.
I watched it.
Yep.
Oh,
I watched it.
I'm pretty sure I saw that on my calendar like yesterday during Columbia.
Okay. So the deal is, like those intro videos aren't in there. It's just like it would be nice if. It's sort of like a 10-minute, like, I don't know if we can fit this into class, so you need to show up with like some basic idea of what this is, instead of not doing it. So I'm going to do my best to navigate this. But some of you, I don't know, hopefully you'll be able to follow it.
Just start like we watched the intro video and we'll be fine. We'll figure it
Really? Okay, then do number 2.
out. Okay.
Go.
I'll just read on the top.
I watched the intro video. I don't even know if I can do it right now.
I don't know. He said do it as if we had learned from the intro video. So if you learned all you can, then you should just do number 2. Or maybe I'm just taking this suggestion. Maybe that's too aggressive. I don't know.
Yeah, I'm saying I watched it and I don't know if I can do it.
Okay. I need to do some serious zooming. Well, I'll tell you what. Hey guys, listen. So my plan for today was to hand your tests back to you, the parametric vector polar tests. So I'll take some time out of that right now to basically reteach the intro video stuff. It seems like maybe that's what I need to do, so I will definitely do that. But I would say I would so strongly encourage you with the idea that you're losing out on something because I'm doing this. And I think there's 1 or 2 more intro videos coming up in the future. Please don't look at those as just sort of like a, whatever. I mean, at least try like you did. I would encourage everybody to do that. So here we go. Alternating series are, this will piggyback off of yesterday. These are basically series whose terms go plus, minus, plus, minus, minus, plus, minus, plus. And these are very, very common. You already saw these. Listen, please. Hey, it's just a cucumber. You already saw these on day 1. Remember, sine is alternating. Cosine is alternating if we look at the basic power series for those. And there are others as well. So these will show up a ton. The way that I like to look at these is I like to separate them out. So I would look at the elements in the blue box and the other blue box. I would call those 2 things the alternating elements.
So that's
with the n inside of it, or out, sorry.
Yeah, because the n is going to go 1, 2, 3, 4, 5. So if you take negative 1 to the 1, you get a negative. If you take negative 1 to the 2, you get a positive. You can see basically it's an even odd exponent process there. Meg, do you have your notes packet ready to roll there? If you don't have it, I've made extras. And then the items or the elements in the pink box, that would be the rest of the nth term. That would be the part that makes it a geometric series or a p series or a harmonic series or whatever. So that a sub n could be super complicated. It could be super simple. Could be somewhere in between. So we've looked at a bunch of a sub n's. We've looked at a really wide variety of a sub n's so far. That alternating element is what makes this one new. So as I mentioned last time, this is kind of the direct opposite of the nth term test. This is the soccer mom. Basically, if you can just like get on the team, you get the trophy and the juice box and the apple, right? I mean, everybody feels good around soccer mom. So as long as we can get this to be an alternating series, like get it on the team of one of these decreasing alternating series, then we're going to be in good shape as far as convergence and divergence. So these alternating series will converge if the following two conditions are met. So number one, the nth term needs to head towards 0. So this is the nth term test, isn't it? Mm-hmm. So if you have an alternating series, so you got to notice the plus minus pattern, and the nth terms are going towards 0 consistently, right? So that, let's look at this notation right here, this a sub n plus 1 is less than or equal to a sub n. Wouldn't n plus 1 just be the next term?
Sure.
So if every next term is less than or equal to the previous term, so in other words, the terms are steadily decreasing, or not increasing would maybe be another way to put that, then we're in good shape. So let me just say right here, you see the box over there? You can sum up those two conditions by saying decreasing in absolute value towards 0. Decreasing, that's what we're talking about here. This is decreasing, and this is the towards 0 part.
Isn't that saying the same thing? Because if the limit is 0, wouldn't it be even smaller every time? Every next?
Not necessarily, because you could have a series whose terms go here, 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 here.
Oh, yeah.
Right? So that's definitely heading towards 0, but there were some parts that were increasing. And so what would we do there? We would just chop it off there and look at the convergence or divergence from there. And of course, this is alternating, so those terms would be flip-flopping sides, but from an increasing, decreasing perspective, that's what that's saying. So we basically need to check to see what the nth term is doing and make kind of a mental note that we would write down that the terms are steadily decreasing. And if those two conditions are true, it's a really easy test for these series to pass, right? They'll end up converging. So if we looked at number 1, and this is where I'm going to drop you all off, and we'll do this one together, but I'll drop you off here, and I'll let you try number 2 and 3, stuff like that. So the first thing you want to recognize, so we're just determining convergence, divergence. The first thing you want to recognize, and you want to write this down, is this. The series is alternating. How on earth would you happen to know that?
The negative 1 to the n plus 1.
Yeah, that's right. So this piece right here is your alternating element. And so having that sitting right there in the front tells you that these terms are going to go, well, in this case, it would be what? Positive, negative, positive, negative, positive, negative. Okay, so its series is alternating. And the limit, as n heads towards infinity, of 1 over n, which is that's the a sub n part. That's the part of the nth term that's not the alternating part. What does this equal? 0. And I want to just think this through now and say, all right, so as n goes from 1 to 2 to 3 to 4 to 5, are we going to see a consistent decreasing pattern?
Yes.
Sure. So, yeah, come on. if a sub n equals 1 over n, then a sub n plus 1 is less than or equal to a sub n for our interval. Okay, so as n goes from 1 to 2 to 3 to 4 to 5, that next term will always be a little bit smaller than the previous term. We're seeing consistent decreasing pattern. And all I want you to do is just write that observation down. We don't have to get into like a derivative and say, hey, look, the derivative is always negative or something, therefore we see steady decrease. I mean, you can, of course, do that. But all I want you to do is make that observation and then write down, hey, this condition's true. So if we have an alternating series and the terms are decreasing in absolute value towards 0, we can then say, therefore, the series converges, and it's named the alternating series test. We can just write AST, just like we did GST for geometric series test. Alternating series test is here. So like I said, this is a really easy test for these series to pass. Go ahead.
I don't know why a sub n plus 1 being smaller than a sub n.
So I would just encourage you to do like basically a partial writing out of the series, right? So let's just mentally try this out. So if I start at n equals 1, like I'm supposed to, and I'll ignore the alternating piece because we know it's going plus minus plus minus. So if I just focus on this part right here, and I say, all right, if n is 1, what's the term?
Well, 1 over n.
It would just be 1, right? If n is 2, what's the term? And then 3, 4, 1/4, so it'd be 1/4, 1/5, 1/6, 1/7, 1/8. So what we're looking at there is, what's the relationship of, maybe I should write this out. What's the relationship of the previous term to the next term? So something like this. Can you see how 1/2 is smaller than 1?
Yeah.
And 1/3 is smaller than 1/2, and so on and so forth. So that's what this is talking about. It's saying is the next term, n plus 1 is the next term. Wherever we are, n plus 1 is the next one.
A of n plus 1.
Oh, you know what?
That's what
I kind of, you know what? I wrote that in sort of an awkward spot, and I can see how you would think that.
That's why I was.
Let me see if I can control.
Plus 1.
Yeah.
Does that look a little bit better?
Yeah, that makes, yes.
It
Okay.
was typed up there kind of nicely, and then my one sort of crept up a little bit.
Okay,
No, that's
that makes a
perfect.
lot more sense.
Okay, good. Yeah, thanks for asking.
Got it.
Sometimes it's just a little minor rewrite makes all the difference,
Yeah.
right? Okay.
No, thank
Okay, so the things you need to have here, I'll put these in a yellow box. You have to identify that the series is alternating. You have to call it what it is, right? Because if it's not an alternating series, or you don't know, or we're confused about that, then all the reasoning later on not going to make a lot of sense. I do want you to write this. Okay, so I want to see that the limit as n goes towards infinity is heading towards 0 and steadily decreasing towards 0. And all you have to really put is that right there. Like I said, I'd like at this point, especially if you're prompted to actually name the thing you use, like the alternating series test. But if you got those 3 yellow boxed elements in place, you're in good shape. Yeah, Santi.
So if the series that doesn't meet the two conditions, is it diverging?
No, so that's the thing. This is the opposite of the nth term test. So if a series is going to diverge, then the soccer mom is just like, I just don't want to look anymore. Or they'll go back to their minivan and get the juice boxes ready. You know, if someone falls flat on their face in the soccer game, they'll clap and say, you're trying so hard. They won't tell them that they're bad, right? They won't say that was a bad move. So for instance, so Sandy, let's talk about that. Let's say you did,
Number 2.
well, hang on just a second. Let's say you did this. Let's say you did limit as n goes towards infinity of whatever it is, and you got something other than 0. The alternating series test would really just be silent, because it'll only tell a series that it converges. We would know that if we did the thing in the green box and we got something other than 0, we know that we would get a diverging series, right? But the reason wouldn't be the alternating series test. It would be the nth term test, right? So yeah, it's the polar opposite of the nth term test, really. Okay, so why don't you all try number 2? A little manipulation to be handled here before you get going too far. And I'll let you guys work on that for a moment here. I'm going to kind of assess where I'm at. decide how I want to proceed. Okay. Hey, and just a reminder, we talked about this yesterday. Tomorrow is your
Quiz.
9, 2, and 3 quiz. So that would be nth term test, geometric series test, integral test, P series, harmonic. Those 5, yeah.
I am not going to be here tomorrow.
Okay.
So can I have tests on Monday? You have maybe on Friday, or I could be here on, or on Tuesday.
I think Navy on Monday would work fine, me. Number 2, right? Number 2? Yes. Oh, wait, no. This is weird. Oh, no, we got the, sorry. I was confusing 2 and 3. I thought for a second there we had different notes.
First turn.
Okay, so we do a little bit of work here, a little manipulation to get this one more clear. I think would make a lot of sense. So the n in the numerator has got to stay right there. And I guess I'm just thinking this to me makes the most sense. I would rewrite this, and this might seem a little bit weird.
Is that how you
Why on earth would I rewrite like that? You can see the alternating a little bit more clearly, right?
We don't have to do that to prove that it's alternating, right?
Nope, you don't. Definitely do not. But I'm going to write it out like that just so I can kind of see it there. And so the first thing you want to say here is the series is alternating.
If I draw an arrow to what makes it alternating, and I just write alternating series and element, will that work for justification?
I would encourage you to use complete sentences rather than like little snippets.
Okay.
So if you just say the series is alternating, period, that's a complete sentence. I like complete thoughts because you're saying here's what's important.
Okay.
So do your best with that. I mean, I think if you identify and say, hey, look, it's an alternating series, that's pretty good. Yeah, I think that's pretty good. Okay, so then it would be the limit as n heads towards infinity of n over 2 to the n minus 1. So you think that equals 0?
Yes.
Why would you say that equals 0?
Because any a to the n plus c or whatever, that's what matter, will always head towards infinity faster than a polynomial.
Oh, yeah, so a geometric or a exponential on the bottom, right? Yeah. Will always eventually be infinitely steeper, right, than a polynomial. Yeah. Did anybody do any further manipulation than that? I don't know if you did. This might help you see a little bit here. So you could say limit as n goes towards infinity of n over, wouldn't it be 2 to the n times 2 to the negative 1? Santi, did you have that?
Yeah, I mean, I didn't do it.
Okay. So then, couldn't we then write it as 2n over 2 to the n? So this, to me, like Jack's point, this becomes a little bit more clear, right? His point. Now, the top is now clearly a polynomial.
Yeah.
The denominator is clearly an exponential now. So if you think about that rankings thing we talked about in the past, or you could use a L'Hopital's rule and get there in one step, I think. I think we'd see that this limit does head towards 0. And then do the terms steadily decrease?
It also says
Say again?
it also says that it could be equal.
Or equal to, right? So yeah, we say steadily decrease, but with the possible exception of maybe having some terms that are equal. So let's see here. Yeah, the first term would be, what, 1? 1, yeah. Second term would be 1, would it not? Third term This would be 3/4, right? So it'd be 1, 1, 3/4. Now I think we're going to see steady decrease beyond that. So I think we can say, and if a sub n equals n over 2 to the n minus 1, a sub n plus 1 is less than or equal to a sub n. Boy, that 1 kind of crept up there again on me, didn't it? Sorry. 1 to infinity. Let me see if I can fix that. That 1 creating problems for everyone. There we go. Okay. So basically what we've shown here is the terms decrease towards 0 and steadily decrease, or, with the exception of the first two terms, which are equal. Therefore, we can say by the alternating series test, the series converges, and we're done. Hanging in? You're going to get more chances to practice this in the midst of our next little sections, couple of sections here. But would you guys try number 3?
Do you have to break it up? Like break up the -1 and...
We're talking about number 3?
For number 2.
For number 2. So do you have to break it up
To
to...
-1 to the n minus 1 times 2 to the n minus 1?
I don't think so.
Because if you did it, then we just pull out the -2 to the n minus 1 and do the limit as n goes to infinity of just n.
No,
So how would you do it?
So I think in that case, you either have to like physically pull it out and see it, or just like mentally see it and test the limit,
Okay.
right? Because the -2 to the n minus 1 is more than just the alternating element, right? So the alternating element will always be -1 to the something.
Mm-hmm.
And that's obviously a 2, which makes it more than just the alternating element.
Now we have factorial.
Oh, factorials are awesome. In fact, our next and final series test will specialize in factorials.
No.
Oh yeah, it's going to be awesome. Hopefully this first statement is pretty apparent from looking at the nth term. So Aiden, when you analyzed this, what'd you get? Pretty strong 0, right? Like it's going to get close to 0 really fast. It's not going to take very many terms where you're like, it's basically 0, right? Okay, and then did you find this to be true as well?
Why did you n goes to 0? Why did you do this?
Why did I do what?
N goes to 0.
Oh, should be infinity. I was thinking one step ahead, and I said I was thinking 0. Very strong 0. I think I was thinking that and I wrote it. Sorry. Yeah, limit as n goes towards infinity would be 0. So if a sub n is that nth term element, is this true?
Yes.
Again, this would be a very strong yes, right? I mean, very apparent if you were to graph these terms out. They decrease consistently for our interval. This might be a point in time. I don't know if you noticed that the low limit on the sigma is 0. We talked about this a little bit. Jack did this thing back there. I did mine up here on the front. We talked about 0 factorial is 1, right? Because at first you could look at this and say, wait a minute, 0 factorial, that's got to be 0, right? That's really 1. So it does. This actually does hold here. Okay, so if you can show those things, we'd say, therefore, the series converges, and the reasoning would be based on the alternating series test. So you see why I call this the soccer mom?
I love soccer.
Like if we can just like fit it into this category of, hey, the terms are decreasing towards 0, decreasing in absolute value towards 0, we're done. Okay. So do you guys remember, bless you, do you guys remember day one of all this series stuff when I started to, I don't know, I told you I was going to kind of mess with you, and then I did mess with you, but then you guys picked up on it really quick. Remember we did the graph thing? I said, hey, what does this look like? And you all said y equals x, and then I zoomed back out, and you're like, wait a minute, it's sine. Remember we're doing all that stuff? Do you remember how we tried to make the interval of convergence go from here to here to here to here? You make it wider and wider. And each time we did that, we were trying to deal with the error associated with the fact that we were approximating like a sine or a cosine or something with a polynomial. So we're starting to make our way back around to that right now. It's going to take us a few days for sure. But I want to look at what's called the alternating series error bound or the alternating series remainder. And so for the first time, what we're going to be looking at here is essentially, okay, if I use an alternating series, and it goes on forever, this plus this minus that plus minus plus minus plus minus, goes on forever and ever and ever. If I cut that series off, if I say I only want the first 20 terms, we're going to try to answer the question, okay, if I only include the first 20 terms, what's my error? Like, what's the worst it could be? How far off could I be? That makes sense? And so we're going to look at two of these. One of them is called the alternating series error bound. The other one is called the Lagrange error bound. And we'll look at that later on. Lagrange is the guy's name. Sounds much scarier than this, but whatever. We shall see. So and I'll give you a little graphic on this here in a second as well. But if you've got a converging alternating series, and you have a partial sum, right? The first 10 terms, first 20 terms, the first 5 terms, whatever it is. Then, would you guys agree with me that this would be a good symbolic representation of the error? Wouldn't the error essentially be the actual sum? Oh, let me try this. The actual sum minus the partial sum. Wouldn't that give you your error? Like if you knew the true sum and you subtracted the partial sum, that would tell you how far off you are. And in fact, when we did the calculator activity on that first day, isn't that what we did? Didn't I set up one of my equations to be sine minus the polynomial? You remember that? I said, hey, sine minus the polynomial. I said, what does the error look like? And you all said, it looks like a cubic or a negative cubic or something, right? I said, okay, that's right. And then we added another term on, and I said, well, what does that look like? And it was like, well, that looks like a 5th degree polynomial, right? And so then we added that error on, and we kept on trying to like scrape off a little error, scrape off a little more error, and get better and better and better at what we're doing. So error equals actual sum minus partial sum. Conceptually, does that make sense? Okay. So here it is, and just in a nutshell. If the alternating series is a converging alternating series, then the error, also known as the remainder, I'll put this right here. I'll say this is the error. Some people refer to it as the remainder. It's the same thing. Is less than or equal to a sub n plus 1. So what's a sub n plus 1?
It's the next term of the series.
It's the next term. That's right. Some other ways that this is put. Maybe this will make sense. Some people call this the first neglected term. First neglected term. Like the next term would be the first neglected term. So let's see. I wish I would leave myself a little bit more room on some of these things. Let's do this. Are you okay with this? I'm going to erase this and do some zooming so I give myself a little bit of room. You okay with that? Okay. So check this out. Now I've got room. Okay, so if I had a series, I looked at this graphically, maybe the first term is here, and the second term is here, third term there, fourth term there, so on and so forth. Can you all tell that that is an alternating series?
Yeah.
Okay. Can you also tell that it's a converging alternating series?
Yes.
By all appearances, right, you see how the terms are heading towards zero in a steadily decreasing pattern if we take away the alternating element. So let's just do a for instance here. Let's say that this series is, I'll just make up some numbers here. Let's say that it's 2 minus 1 plus 1/2 minus 1/4 plus 1/8 ... Can you buy that from my graph? Okay. So then what this alternating series error bound is saying is if you take this series that goes on forever and ever and has a sum of something, right, some number, and I decide to cut off the series and do a partial sum. So let's say I said my partial sum, so this would be 1, 2, 3, 4, 5. So I'd say S5 equals 2 minus 1 plus 1/2 minus 1/4 plus 1/8. So I'm acknowledging that this is a partial sum. It's not the exact sum, but it's an approximation for the real true sum. What I would maybe want to do here is say, all right, that's my approximation. What's the worst my error could be? So if this is a converging alternating series, what we would say is that my error, which would be S minus S sub 5, would be less than or equal to the first neglected term. So what term did I leave off? 1/16, right? It would be minus 1/16. So I always look at this as far as like in terms of a positive number. So I would say that my max error is 1/16, because wouldn't the next term out here have been minus 1/16? So with the alternating series error bound, the first neglected term, the first one you left off, is going to be your maximum error. So I don't know, 1/16, is that an acceptable error to you?
Sure.
Kind of depends on what we're doing with it, right? It might be. What if 1/16 was unacceptable? It was way too big of an error bound.
We'll just keep going for a while.
Add some more terms until that error gets small enough to be acceptable to you. That make sense? Let's talk about why this is. So this kind of goes along nicely with what I talked a little bit about yesterday. So let's see, this would be 2, this would be -1, this would be 1/2, this would be -1/4, and this would be 1/8. So the next term would be -1/16, and that of course would be like right there. It'd be super close to where that x-axis would be. Why would this then be the biggest possible error? Because aren't I cutting off a lot more terms over here? Like how many terms did I really cut off? An infinite number of terms. So how could that first neglected term be the biggest error? Because wouldn't you think that the error would be bigger than that?
Well, it's the biggest term, and it's going to be out of all those that follow.
And the ones that follow will decrease towards 0, and they alternate.
Oh, shoot. Yeah.
Okay, so if I looked at this and I said, hey, this right here, this is 1/16. The absolute value of it is 1/16, right? Well, then wouldn't the term after that be slightly above and be positive and slightly less than 1/16? So every next term would actually decrease the error. Because if you've got -1/16, then this would be positive 1/32, and then negative 1/64. As you continue to add those, wouldn't the error actually narrow down? Because of the alternating nature and the fact that the terms are decreasing towards 0. So the worst it could possibly be is that first neglected term, again, due to the fact that you're going plus, minus, plus, minus, plus, minus. And so the error would be this big, then this big, then this big, then this big, then this big, the more terms you added on. So the biggest the error could be, the worst your estimate could be, would be bounded by that first neglected term.
And that's a factor we want to prove.
We're gonna just settle on that. Like
Okay.
this is my proof of this right now, just like a graphical proof. Like think about how the plus minus would work together and actually decrease the error. Instead of, now think about it, if the terms didn't go plus minus, plus minus, plus minus, well then, hold on, then all those terms say would all be positive. Wouldn't the error go up with each term? So for non-alternating series, that's where that Lagrange error bound comes into play. So I'll have a different way of expressing that.
Thank you.
And so the error bound naturally there is going to be bigger, will it not? It'll be bigger.
If you have negative 1/16th and you add 1/32, that's going to decrease the error. But if you add negative 1/24 to that, wouldn't just.
Well, then the next one would decrease it,
but
right?
It's at a smaller amount.
Say again?
It'll decrease it by a smaller amount.
Yeah, but you decrease the 1/16th by a bigger amount than what's coming next.
So it just like evens out. Kind of.
It more than evens out. It like gets closer and closer and closer to zero error the more terms you add. That's because of the plus, minus, plus, minus, plus, minus. If it was plus, 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 that's something else entirely. Or plus, minus, plus, minus. Isn't there a small degree of canceling out with each one of them?
Yeah, a little bit.
Each one will cancel out a little bit, and a little bit, a little bit, a little bit, a little bit. And it cancels out less because there's less to cancel out, right? So you had 1/16th, well, you subtract 1/32, now your error is 1/32. So then you subtract a 64th, right? Now your error is a 64th, and you subtract 128th, right? You see the error just keeps getting smaller and smaller and smaller. So the worst it could be, and this would be an interesting thing for like even an engineer or a financial person, if you were giving a report and you said, well, I estimate the financial blah, blah, blah situation of such and such, and what if your boss said, well, okay, I get your estimate there. How far off could you be? If your response is, I have no idea. That's probably not a good thing, right? Or if your response is like, I don't know, plus or minus $1 billion, and you're just sort of like making stuff up, that's not good. But if you could say, hey, I've modeled this with this particular series or this particular function, and I know based on blah, 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 that the worst my error could be is 62 cents or $100,000 or something where you can actually back up your claim. Well, now your boss would say, okay, 62 cents, that's an acceptable error for sure in my book. Let's move forward with your plan. Or $100,000, if you're off by $100,000, that's a big problem. So we need to rework this, and you need to rethink your estimates on how much is it going to cost or how much we're going to make or how much whatever, right? So we're trying to basically control our error using the alternating series error bound. Does that make sense? Okay, so let me see what's up ahead here and see how much I want to do. I want to do one thing with this. Okay, so let's do this one together. So let's definitely work through A. We'll work through A fairly quickly because this is really similar to one we did just a few minutes ago. And then we'll work through B fairly quickly, and we'll spend just a few minutes on C. So
Is this like an actual FRQ?
No.
Just curious.
No.
It's too narrow focused.
Yeah, way too narrow of a focus. Yeah. You'll see some soon. Okay. Hey, quick eyeball test. Does this series converge or diverge? Definitely converges, right?
Yeah, okay.
So
You said it too fast and then I got confused.
the first thing you'd want to say is the series is
Alternating.
alternating. That's right. Series is alternating. And if I do that limit as n goes towards infinity of my nth term without the alternating piece in there, what do I get? That's a big fat 0, is it not?
It's a thick old 0.
Very quickly heading towards 0 because of the factorial there. And if a sub n equals 1 over n factorial, again, hopefully this is also clear that the next term will always be less than or equal to the previous term on our interval. Therefore, the series converges. And our reasoning there is based on the AST. So again, hopefully that goes really nicely with what we did at the start of class. So B says approximate the partial sum S5 by its first 5 terms. So Meg, what's the first term?
1. Or wait, no. Yeah, 1.
I agree. It should be positive, right? Because it's negative 1 squared.
I psyched myself out.
Okay, Julia, how about the second term? Negative 1/2. That's right.
Go Bucks.
So we're starting to see this alternating pattern emerge. Nick, how about the third term?
1/4. Wait, no. What's it?
I agree with the positive, and you say it's not 1/4 now. You say it's 1/6. 6th. I agree.
Good boy.
Well done. Santi, how about 4th term?
Wait, how is the second term negative 1/2?
So second term, you'd get negative 1 cubed. Negative 1 cubed is negative 1.
Mm-hmm.
And then 1 over 2 factorial. 2 factorial is 2.
Oh, yeah, okay. There we go.
It's okay.
So much encouragement on this side of the room.
I was rubbing.
Very
It
heartwarming.
was endearing.
It wasn't for me. I didn't need to show the TikTok in order for Mr. Anderson to fully get
It'd be negative 12.
TikTok up.
Negative 12?
I don't even do that, actually.
I don't agree
I'll ask you.
with, Santi, I don't agree with negative 12.
What's that? Or negative 24. That's what I meant.
I don't agree with negative 24 either.
Not really.
I think it's just like a minor oversight. Wouldn't it be minus 1 over?
Negative 120. That's what I said.
Oh.
Wrong thing. But I wrote it down differently.
Okay. And then,
No,
Aiden, how about the final 5th term there? He did, yeah, he said 1 over 120. Okay.
Get it.
There's our partial sum, and we could add all those up. The common denominator would be 120. Wouldn't be that hard for you guys to do. We'll leave that alone. So C says, using the alternating series error bound for S5, find the maximum error if using S5 to approximate the actual sum. So I want to show you some notation here. Here's how I would start this off. I would say because the series is converging,
Can you just say the series instead of actually writing out the series?
sure, is I'm going to say a converging alternating series. We have a converging alternating series. The error is bounded by converging alternating series. The error is bounded by the first neglected term. So I'm just spelling out my reasoning for doing this. And I'll put the actual notation over here to the left. So I'm going to say absolute value of S minus S5 is less than or equal to the first neglected term. And what would be that first neglected term?
720.
1 over 720.
Don't we have to do the absolute value?
So
Oh, you can just say.
I'm just doing absolute value of S minus S5. So
Put 5 in for N.
whether it ends up being plus or minus, I am going to do the absolute value of that first neglected term. And so I know the next term is going to be negative 1 over 720, so I just write this as 1 over 720. Okay, so, and that's it. So what you could do with this here is you could say, I've got my partial sum up there, and the worst my error could be is 1/720th, which is pretty small, right?
Why is it not negative?
So we always look at error as just a positive number, and just say, hey, the error, we could be off by 1 over 720th, we could be a little too high, we could be a little bit too low, but we always present it just a positive number.
So if you wanted to keep it negative, would you take out the absolute value?
If I wanted to keep it negative,
If you did negative 1 over 720, would you just not do the absolute value?
just don't even do that. Just make it always positive number. Okay, I would like to hand some stuff back to you guys right now.